the last several modules have been focused on a lot of theory, figuring out how to work different types of problems to find extrema, whether local or absolute. Um, Now in Module 9.2, we really get to start tying all of that theory together to look again at some important application problems. We're going to be looking at concepts from several of the different modules that we've covered, but if we really want to focus it down, in Module 9.2, we're really specifically taking the techniques that we covered in 9.1 and 7.1 to solve what we refer to as optimization problems. There's not a lot of new information to introduce in this section except to establish kind of a procedure for how to think through and work through these problems. But beyond that, it's just taking these concepts that hopefully you've already come to understand and completing these application problems. So what we want to do is essentially when we're solving optimization problems is find optimal values, maximum values, minimum values. In the context of business problems, what we're looking to do is maximize revenue or profit, or find the values that minimize our cost. So let's set up a basic strategy for solving these types of problems. Every one is going to be a little bit different, at least on the setup side. But once we have the setup completed, more or less we'll be following the same pattern for each problem. So the very first thing to do is to take the information that we're given and construct a mathematical model that's going to say either maximize, or similarly we could have a problem that would say minimize some function f of x on the interval I. Whatever that interval happens to be, there will be some boundaries or restrictions placed on our problem that will be given to us in the problem or that we can derive from the problem that we're given. So the key here is that you're going to have to read these problems carefully in order to establish this model. So essentially this function f of x isn't going to be just provided for us literally. The interval won't be just directly provided for us. We'll have to use some inference and some common sense to put those together. And whether we're looking to maximize or minimize, again, is going to be based on the context of the problem. So once we have our mathematical model, we'll need to identify any critical values of our function f of x. And again, finding critical values means we take the first derivative and figure out where that would be equal to 0, or take the derivative and figure out where that would be undefined or where it does not exist. So after we have our critical values, we'll use the procedures from either module 9.1 or 7.1 to find absolute extrema. So that means we're going to start off by trying to apply the second derivative test. And then in a case where the second derivative test is inconclusive, we'll take a look at the first derivative test and use that as our backup approach for finding maximums and minimums. So once we have all of those results, we'll use those solutions, so whatever we find to be our absolute maximum, absolute minimum value, we'll use that solution to answer application questions. So the idea here is that in real life, we're not given formulas, we're not given equations, we're not given boundary values to consider. The goals of the problems in this module are really to better emulate the sort of things you would encounter in the real world. We need to take some given information, establish the model, and determine what it is we're trying to answer. Are we trying to minimize something, maximize something? And then once we get these results or solutions, what context can we apply to that? What types of questions can we answer rather than just reporting numerical values?